in this question, we're solving for x. And this is using the relationship that we have between a central angle and an ascribed angle, and the arc that both of them make. In this case, it's the same arc AC. So what I'm going to do is I'm going to do a little work here to start. I know that angle ABC equals 5x minus 2. And I know that that central angle is equivalent to arc AC. So let's figure out what arc AC is first. I know that the inscribed angle AGC is 64. So to get the arc, I'm going to double that. So I know that that dotted arc AC is 128 degrees. So I can set 5x minus 2 equal to 128. If I add 2 to both sides, 5x equals 130. And when I divide by 5, I believe we get x equals 26. If you don't understand something I did on the board as I'm going through these questions, raise your hand. I can either explain it a different way, or if there is a different way to solve the problem, we can talk about that as well. In this case, x will equal 26. And if you're confused on why you may have got it wrong, it may be that you did the question right and that the way you wrote it in there is not the way that Edulastic accepted it. And I can tell you if that's something that you still did it right, or maybe you knew how to get the correct answer, but you didn't simplify it correctly. So we can talk about that as well. I want to go over here, 10. 18. All right, so 10, and I made the test, and I'll say that a problem similar to this one on the test has values that are a little more to scale. This one is not, but we can still use it. BE is 16. I'm going to write that down to start. That length is 16. DE is 65. And angle ABE is 90. And we are trying to find the length AC, that segment. Okay. Now what we know about this is that this radius, that's the same length no matter where I draw it on the circle. Okay. So if I draw another radius, that's also 65. And I now have a right triangle where I know 2 of the 3 lengths. So I can solve for that missing side length, which I know is going to be half of AC. So I got x squared plus 16 squared equals 65 squared. When I solve for x here, I'm going to get x equals 63. And if this is 63, so is this. So to find my full length AC, I just add those two together. I get 126. Again, not drawing the scale. Okay. But AC would equal 126 in this case. But the key to these types of problems is that if you're given a diameter or a radius, you know that that's the same diameter or radius no matter where you draw it. So you're able to construct some different segment lengths that you know the length of, right? Which can then help you construct something else, in this case, a right triangle, that you can use to solve for your missing lengths. mean, I guess you could have looked at this as two right triangles, where you're solving, and getting 63 for both those. But either way works. All right, number 18. All right, solve for x. We have two chords that intersect. And we know that if we take the two segments from, we'll call this the blue chord, all right, and multiply the two segments together, 5 times 8, it'll equal the multiplication of the two chords, two segments from the green chord. Now, when we do this, though, 5 times 8 is 40. X times 2x, that's not 3x. And I think that's where some people are getting confused. If it were x plus 2x, that would be 3x. But x times 2x is going to be 2x squared. When I divide both sides by 2, because in order to solve for x, I need to get x squared by itself. So when I divide both sides by 2, we'll get 20 equals x squared. They want our answer to the nearest 10th. So when I take the square root of both sides, I don't need to do a simplified radical of radical 20. I can actually take the square root of 20. And when I round it to the nearest 10th, I should get 4.5. I want to say it's like 4.47. Then you round up to 4.5. There's 18. And 20. 20 is where we got two secant lines that intersect outside the circle. And our segment lengths here, we always are going to multiply outside times whole equals outside times whole. So if I look at the top line, the outside is 3, and the whole is 3 plus 5. You look at the bottom line, the outside is 4, and the whole would be 4 plus x. 3 plus 5 is 8, and 3 times 8 is 24. If I distribute on the right side here, that's going to be 16 plus 4x. Subtract 16 from both sides. 8 equals 4x. And if we divide by 4, you get x equals 2. Outside times whole equals outside times whole. Works for secant lines and for tangent lines. All right, those are the 4 I want to make sure that I went over. Are there any others that you have questions on? I know the second period had 3 or 4 others that they'd like to go over. How about you guys? Any others? Don't be afraid. Get me 3. And I'm not forgetting about you guys at home. I'll check your chat here in just a second. So number 3. Identify the center and radius of the circle, whose equation is given below. If the radius is not a whole number, leave your answer in radical form. So, standard form of a circle, x minus h squared plus y minus k squared equals the radius squared. So we're identifying our center is going to be at h comma k, and our radius is r. All right, well, this is x minus 3, so our h value is going to be 3. and y plus 5. It's supposed to be y minus. So if I were to rewrite this so it'd be y minus, that's y minus a negative 5. So our k value is negative 5. So the center's at 3, negative 5. Our radius, this number here is the radius squared. So if I want to solve for just r, it's the square root of 31. It says leave your answer, if the radius is not a whole number, leave your answer in radical form. If I can simplify this, I would get a simplified radical, but you can't simplify radical 31. So that'd be my radius. Yeah, so that's an exact answer. We could get a decimal, we could round it. But I like the fact that we're keeping it exact with circles, because we want to know exactly how big the circle is. All right, I got a number 11 question. Go to that one, and then we can, if anybody else has others, please let me know. All right, I like this problem. So there's a property that we need to know when we're doing number 11. And they tell us that Kj equals ML. So these chords are equivalent in length. And the property we know about with this is when the chords are equal, the arcs that are made from those endpoints are also equal in measure, length and degree. So if we're told that ML is 60 degrees, Kj is also 60 degrees. If we know these two are both 60, and we're also given that JL is 70, and we're trying to solve for angle KNM, all we need to do is identify arc KM, and we know that it's equivalent to angle KNM because it's a central angle. So if I add these three angles together, 60 plus 60 plus 70, I get 190 degrees. To get arc KM, I subtract that from 360, and I get 170 degrees, which is what the angle also equals. So again, the key there is that you have two chords that are equal in length, which makes the arcs also equal in measure. In this case, we use the degree measure because that's what we're going to need for the angle. All right. Anybody else out here? Questions? How about anybody at home? Any other questions you guys have? Again, I know there were a handful of people that didn't have their review completely finished. Now is a good time to do that. If you have questions on the review or any other previous assignments, now is a good time to ask. You guys are going to be assigned the test right when class starts tomorrow. You should be able to finish it during that class, that allotted class time tomorrow. Okay. But I recommend you get in here and you get started on it right away.